In this lesson, we will look at the main steps carried out during an ILS approach. In particular, we will look at the ILS display on the PFD, the radio altitude RA display, the auto callouts, and the indications when passing the marker beacons. In the last lesson, due to a glide slope failure, we tried to make a non-precision approach at London Heathrow, runway 27 left. Because of bad weather, the approach was aborted at minimum descent altitude, MDA. In this lesson, we're going to make an ILS approach on runway 27 right. We're now in the holding pattern at Epsom. While in the holding pattern, you can set up the ILS. There is one ILS box fitted to all aircraft, and it is located at the top of the centre pedestal between both VOR panels. Next, we will look at the procedure for tuning the station and setting the course. First, the VOR nav ILS switch on the EFIS complementary control panel must be in the ILS position. Do this now. As soon as ILS is selected, the localizer deviation scale appears on the PFD. The glide slope scale also appears on the ND. Next, you tune the ILS station. Perform your next action. The correct frequency of 110.3 MHz is displayed on the ILS box. When the localizer and/or the glide slope signal are received, a half diamond will appear in the respective scale. These diamonds will appear as closed when the aircraft is within 2 dots of capturing them. Next, set the course. The ILS course is set. The correct frequency of 110.3 MHz is displayed on the ILS control panel. Now perform your next action. You cannot hear the Morse ident until the switch on the ASP is in the ident position. Change it now. You cannot hear the Morse ident yet, so continue your check. The correct station has been tuned. Before we leave the holding pattern, we have one more task, to set the decision height, DH. In this example, it is 200 feet. You set the decision height by first pressing the DH push button on the EFIS control panel, and then rotating the Set button until 200 appears in the window of the EFIS panel. Now you must set up the decision height. Continue with your next step. Now the decision height is set. We have now left the holding pattern and begin to configure the aircraft for intermediate approach. We must change altitude from 3,000 feet to 2,500 feet. To do this, you change the selected altitude on the flight control unit. This is covered in the Auto Flight System, AFS, Chapter 22. Select the forward arrow to see the effect on the PFD. Notice that the selected altitude label has changed to 2,500 feet and that the label is now 1 dot below the line. It will be centered when you reach your new selected altitude. The aircraft is now turning so that we can establish on the localizer. Now we have established on the localizer, and the magenta diamond on the localizer scale is centered. Here's an example of excessive localizer deviation. Note that the localizer scale and index flash. You now fly a level attitude at 2,500 feet altitude until you intercept the glide slope. Now we can initiate descent and will reach the threshold of the runway if the localizer and glide slope diamonds remain centralized on their scales. As you descend, the selected altitude label will rise to the top of the scale. Now let's look at what happens as you descend. As soon as the radio altitude is at or below 2,500 feet, it is automatically displayed on the bottom of the PFD. It is displayed in green numbers as long as the radio altitude is 100 feet greater than the decision height. We are now descending and are below the selected altitude. There is an annunciator light on the right of the EFIS panel. As you pass each marker, the marker light illuminates. You will also hear a buzzer. The buzzer has a different tone according to which marker is overflown. Here, at the outer marker, it is a low tone. When reaching 1,000 feet, the radio altitude is displayed in larger green numbers. It will remain this size until you land.
400.
At 400 feet radio altitude, there is an automatic call-out. There will be call-outs every 100 feet until 100 feet radio altitude. We are now at 350 feet radio altitude and pass over the middle marker. This time there is a medium buzzer. Notice that the horizontal bottom bar on the ADI has begun to move towards the horizon. This begins at about 400 feet radio altitude and speeds up so that the line is on the horizon at touchdown. We are now at 300 feet radio altitude. Because we are 100 feet above the decision height, the call-out is
100 above.
At 200 feet, we have reached the decision height. The call-out is
Minimums.
Notice that at decision height, an amber DH flashes with the radio altitude value on the PFD.
100.
There is an auto call-out at 100 feet. Further call-outs are as follows.
50. 40. 30. 20. 10. 5.
We have now landed. There is no inner marker beacon at Heathrow. If there was, the marker light would have come on and a high-pitched buzzer sounded. If you remain at the same radio altitude, or if at any point on the descent your radio altitude increases, radio altitude will be displayed in individual feet and not multiples of 10. This will occur if, for example, the airport is behind a hill, so that radio altitude increases momentarily during descent. This ends our look at ILS approaches. Select the forward arrow if you're ready to try the quiz.